Okay, let's dive right into this. Welcome back, focused learners, to this comprehensive explainer and masterclass on Cambridge IGCSE physics. I'm your resident strategist, and today we are opening up the examiner's playbook to tackle one of the absolute most fundamental, foundational topics in the entire 0625 syllabus, atomic structure and ions. But listen, we aren't just going to sit here and read through boring textbook definitions today. No way. We are doing something much, much more powerful. We are going to get right inside the examiner's head. We are going to decode exactly what they are really asking when you sit down in that exam hall sweating over the paper. You see, every single year, thousands of students walk into their physics exams feeling super prepared, only to get completely tripped up by the highly specific way Cambridge tests these concepts. It doesn't matter if you're taking 0625, 0651, 0652, 5054, or even looking ahead to 9072, the strategy is the key. Today, we change the game. We're going to look at the exact methodologies that separate average, middle-of-the-road grades from the absolute top tier.
Look at this number on the screen, 15. I want that number etched into your mind right now. Why? Because this single topic area, understanding atomic structure, the positively charged nucleus, electron orbits, and the mechanics of ion formation, accounts for a massive 15% of your total exam marks in these Cambridge physics papers. 15%? Guys, that is literally the difference between two entire grade boundaries. To put this into perspective, let me introduce you to two typical students we see every single year. Let's call them Alex and Sam. Now, picture Alex. Alex is a hard worker, but when faced with a question on atomic structure, Alex completely overloads the answer with raw physics facts. We're talking a total brain dump of memorized data onto the page, but zero actual analysis of what the question is asking. And then, on the other hand, we have Sam. Sam genuinely knows the physics, but Sam constantly rushes. Sam completely misses the specific command word requirements in the prompt, losing easy marks despite totally understanding the core concept. By the end of this explainer, you are going to have the exact blueprint to avoid the traps that completely derail Alex and Sam, securing that massive 15% for yourself.
So, here is our explicit roadmap for today's session. First up, we're covering the core atomic principles. Second, we'll dive into the top 3 examiner warnings pulled straight from the grading room. Third, we'll break down the method mark strategy to systematically capture all your points. And finally, we are going to talk about mastering complex evaluations for those top-tier grades. Let's get into it. Section 1, Core Atomic Principles. This is all about building the conceptual foundation required by the Cambridge syllabus. All right, this brings us to the precise syllabus-mandated definition of atomic structure. And I mean precise. Every single one of you needs to be operating from this exact baseline right now. An atom consists of a positively charged nucleus with electrons in orbit around that nucleus. Now, I know what you're thinking. That sounds incredibly simple, right? But you would be absolutely amazed at how many students, just like our friend Alex, start writing these super vague paragraphs about clouds of negative charge or protons floating around in the middle. No, the examiners are scanning your paper for very specific key words. They want to see positively charged nucleus and electrons in orbit. The nucleus is dense, it's central, and it contains your protons and neutrons, which gives it that net positive charge. Meanwhile, the electrons are bound in specific orbits by electrostatic attraction. Listen, when you use the exact clinical terminology the syllabus demands, you instantly signal to the examiner that you aren't just guessing. You are a top-tier candidate who knows their stuff. And right here, we see the causal relationship of ion formation. This is a foundational concept that simply must be mastered to perfection. Look at the strict relationship on the screen. Positive ions are formed exclusively by losing electrons. Negative ions are formed exclusively by gaining electrons. You know what the absolute biggest mistake students make here is? It's heartbreaking. They write that positive ions are formed by gaining protons. No, that is a fatal physics error. Think about it. Protons are locked deep within that positively charged nucleus we just talked about. They are in the vault. They do not move during basic ion formation. Only the orbiting electrons are transferred. To cement this in your memory right now, I want you to use a simple acronym hack. Think LEO. Losing electrons leaves you optimistic or positive. If you can strictly anchor the process of ion formation to the movement of electrons, you're going to bypass a trap that catches literally thousands of Cambridge students globally every single year. Okay, moving to Section 2. Top 3 examiner warnings. Pay close attention, folks, because we are officially entering the danger zone. Here they are, the top 3 common pitfalls pulled directly from principal examiner reports. Number 1, answers are often far too vague and lack specific details. Number 2,
Students completely forget to check their format and presentation. And number 3, answers are not specific to the actual context given in the question. To combat this vagueness, top students use a highly specific strategy called the PEAL framework. That stands for point, evidence, explanation, link. Instead of just throwing raw facts at the page like Alex does, hoping something sticks, you need to make a clear point, back it up with evidence from the data, explain the underlying physics principle, and link it back to the command word. Now, before we continue breaking down exactly how to apply that PEAL framework to your answers, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back into seeing how this actually looks on a real exam paper. Let's see this strategy in action. I want you to look closely at this comparison on the screen. On the left, we have a typical, super vague answer from our rushing friend Sam. The atom becomes an ion because it changes charge. Boom. 0 marks. Red pen all over it. Why? It completely locks the PEAL structure. It totally misses the how and the why. Now look on the right. We have a specific, contextual answer. The atom forms a positive ion because the data shows a decrease in mass, indicating it lost an electron from its orbit, resulting in a net positive charge. Do you see the massive difference there? Green check marks all day. I'm putting a 30-second timer in your mind right now for your next exam. Whenever you write an explanation, I want you to mentally scan it. Can you explicitly spot your point, your evidence, your explanation, your link? If you can't, you are literally leaving marks on the table.
Let me pause and ask you this directly. Are you making cross-topic connections? Because the principal examiner reports highlight something truly fascinating. Candidates who explicitly reference cross-topic connections achieve significantly higher marks. Imagine your standard flawed answer. To transform that into an answer that examiners love, you need to show them you understand how atomic structure connects to other syllabus areas. Think about static electricity, think about electric fields, or even kinematics when you're dealing with particle deflection. When you link the formation of a positive ion to the broader concept of electrostatic forces, you are instantly elevating your answer from a simple, basic descriptive level to a high-level analytical one. You're showing them you see the whole physics puzzle, not just one piece.
Section 3. The Method Mark Strategy. This is all about securing your points systematically, without relying on just getting the final number right. I really want you to read this powerful soundbite directly from an examiner alert. It says, students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Guys, that quote right there is the absolute golden rule of physics exams. The process is just as critical as the final product. If you mess up a calculation on the net charge of an ion because you punched a wrong button on your calculator, but you explicitly wrote down the formula and showed that you fundamentally understood electrons were lost, the examiner can and will still award you method marks. This is exactly where candidates fall apart. So stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's look at the exact blueprint to guarantee you capture those method marks.
To definitively secure those method marks, you must use the step-by-step procedural framework. This is our physics success blueprint. Step 1. Deconstruct the question. You have to decode those command words. The word describe requires a completely different output than explain. Step 2. Extract relevant data. Let's do a quick interactive workshop right now. Imagine a complex physics data table on screen right now, showing the charge and mass of various unknown particles. I'm starting a 60-second timer in your head. What is the core trend? You must be able to visually scan and extract that the particle losing mass is the one becoming positively charged. Step 3. Select your analytical framework, like our trusty PEAL method. Step 4. Execute with clear working and proper notation. Step 5. Present with correct terminology. This kind of systematic processing safely guides you to the correct answer, every single time without fail.
And please, let's not forget that applying the correct formats and annotations is a professional skill explicitly demanded by the Cambridge Exam Board. Let's do another quick challenge together. Find the flaw. Imagine a student writes this sentence in their exam. The nucleus is positive, so it pulls the negative stuff. Okay, what's the fatal flaw there? It's terrible terminology. Saying negative stuff instantly loses you the mark. The strict acceptable convention is electrons. Now, let's do a 30-second speed writing challenge in your head. How would you rewrite that flawed sentence using strict conventions? You'd say something like, the positively charged nucleus exerts an electrostatic attractive force on the orbiting electrons. Boom, full marks. Clear annotation, appropriate formats, and proper phrasing show the examiner you are a serious physicist, not just someone guessing.
All right, moving into Section 4, Mastering Complex Evaluations. This is the final polish for those top grades. This is what separates the A's from the A stars.
So, the crucial point here is understanding exactly what examiners are looking for when they are grading comparative analysis questions. If a prompt asks you to compare the formation of a positive ion with a negative ion, it is absolutely not enough to just separately define them. You must explicitly identify similarities. For example, pointing out that both processes involve the transfer of electrons. And you must identify differences. One atom loses electrons, the other gains. Furthermore, you must use comparative connectives, words like whereas, however, or conversely. You must support these comparisons with hard evidence from the given data and draw highly justified conclusions. This kind of structured comparison proves to the examiner that you have finally moved beyond rote memorization into true, undeniable conceptual mastery.
Furthermore, to hit that top tier, you must be able to evaluate evidence quality. When you're looking at experimental data regarding atomic structure or ion charge, high-level candidates can easily identify the limitations of that experiment. Ask yourself, what assumptions were made here? Are there alternative interpretations for why a specific particle deflected in an electric field the way it did? When you explicitly address limitations and assumptions in your written exam responses, you are speaking the exact language of the examiner. You are demonstrating the profound analytical depth that Cambridge specifically seeks out and heavily rewards with top marks. So let's take a breath and recap the complete standardized strategy sequence. This is our ultimate cheat sheet system that basically guarantees top marks if you follow it. First, decode those tricky command words to identify the key elements of the question. Second, apply the Peel framework and all relevant physics principles. Third, execute your analysis with crystal clear working so you secure every single method mark available. Fourth, verify your results logically. And fifth, present everything using strict time management and formal formatting conventions. It's a system, guys. Treat it like a science.
I want to leave you with this final provocative question. Will you use the method mark strategy to secure your 15%? The choice is entirely yours now. You have the playbook. You know exactly how to define atomic structure. You understand the strict mechanics of ion formation without falling for the proton trap. And most importantly, you know exactly how the examiner wants you to present that knowledge to them. Listen to me. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep analyzing, keep practicing, and I will see you in the next session.